Hi guys, welcome to day 14. Today we are going to do chapter 8 review, and what I've done is I've only assigned you 3 problems to do, but this is what I'm going to tell you that you need to do if you haven't. You need to start making sure that you have everything you need in here for this week, because we are going to go and we are going to have a test tomorrow. So make sure that you have everything so that you can actually get into this and you'll be able to see what you want to see so that you can show everything that you need. So for day 14, the only thing we're doing here today is we're just doing the problems. That's it. We don't have a one-pager today. We don't have anything else that we need to do. We just need to do the problems. So let's look and see what we've got here. So for 87 in your book, and what you'll do is you'll turn in your book here to 87. Find it. There is 87. And let's look at the first problem. So it says, a constant force on 6 newtons. Sorry, I got to set my timer. A constant force of 6 newtons, okay, that's our force, acting on a 3.0 kilogram, okay, and the object for 10 seconds. And it's asking us what's the change in the object's momentum and velocity. So the only thing we need to do for this is, first of all, for momentum, we just have to take our force and our change in time. So we're going to do 6 times 10, which is 60 newtons per second, or 60 kilograms meters per second. And then the next one, we're going to do our velocity. For our velocity, we also have to include our 3.0 kilogram mass. So for this one, we're just taking our force, change in time, and then dividing it by our mass. So let's get our calculator to make sure we know how to do that. So the first thing we want to do is we want to make sure our mode is right. So we're going to keep it on scientific. So this right here is a linear one. So the only thing you have to do is just do straight up what it says here. And that's where I got, and that's where I got 60. I got 6E1. If I wanted to change that, that would give me my 60. Okay? So I'm going to change my mode back to scientific again, just in case. So this time, what we're doing is we're doing a fraction. And remember, to do a fraction, you do alpha y, enter, and then we're going to take what's on top, 6, so that's 6.00 newtons, and we're going to multiply that by 10, right? And then we're going to divide that by 3.00 over, enter, and that gives me 2E1, which I can change the mode again. Second answer, there's my 20. So then now we're going to look at question number 88. An external constant force changes speed of a 625 kilogram car from 10 minutes to 44 minutes in 6.8 seconds. What is the car's change in momentum? So here we are again, change in momentum. So now what we're going to do is we're going to go and we're going to open our bracket, 625, close bracket, open bracket, 44. But this time, we're going to subtract the initial, okay? Subtract the initial. And then we're going to hit enter. And then I get that number. And if I change this to scientific, that will either give me, if you wrote down 21250, that's fine, or 2.12 times 10 to the 4th power, and that's fine too. So that's the first one, and the next one, we are actually trying to find the magnitude of the force. So what we're doing here is we're going to take our mass times our velocity final minus our velocity initial over the change in time. So it's a fraction again, alpha y, enter. And so what we're going to do is open bracket 625, close bracket, open bracket 44.0, subtract 10 meters, right? Close bracket, and then we're going to go down and we're going to take that away from our change in time, And our change in time is, looking back at the question, is 68. So 68.0 seconds over, enter, and that gives me 3.125 E2, or if I wanted to get in normal mode, I got 312.5, which I moved it up to 313. Okay, so 89. First thing I did for 89 is I went ahead and looked, and I looked at the example that was on the book, and I drew it. Okay, so it tells me, show a gymnast perform a routine. First, she is swinging on the giant bars with the upper bar, holding her body straight. That's what she's doing there, and pivoting around her hands. Then she lets go of the high bar and grabs her knees. That's what she's doing there, with her hands in a tuck position. Finally, she stretches back out and lands on her feet. In the second of the final part of the gymnast routine above, what is the axis does it spin? She spins around the center of the mass of her body, first in a tuck position and then also in a straightened position. Now B, rank in order the greatest and least her momentum of inertia for the three positions. Giant swing A, straight is C, and tuck is B. In C, it says, rank the order of greatest to least her angular velocity. B is the greatest, and then C, and then A. Because if you see, she's in a tuck, right? C, she's standing up, but she's not exactly up because she's got her knees bent. And then A, she's straight up. Okay, and then we're going to skip to 91. 91 says in ice hockey, it says a 0.15 kilogram. And that there is going to be our mass. So I'm going to write that on there. So our mass is it's 0.115 kilogram. Hockey puck moved at 3.5 meters per second. Well, that's my meters, right? That's where they've moved. And it strikes a 30.365 kilogram jacket that is thrown onto the ice by a fan in a certain hockey team. The puck and the jacket slides together. What is their total velocity? So we're going to do the mass of the puck and then the mass of the person's jacket. Okay? So we're going to do this equation here. So let's see what we can do. So we're going to do alpha y inner, and we're going to do open bracket 0.115, close bracket, open bracket 35, close bracket, down, open bracket 0.115, but this time we're going to add 0.365. That is the mass of the other the jacket, over inner, and I get 8.3854, which is 8.39. So my suggestion to you is this. I suggest that you go back over, look at all your notes. I'm going to be posting your test tonight. So what you're going to need to do is start working on it. And then, of course, tomorrow I will also post some help answers, like some equations and things, and tell you which ones you have to work on or not. So I'm going to look at the test today, and I'll make sure that I'll have that on there to tell you exactly which ones that you need. I will, if I have time today, go ahead and post the video that helps you. So whenever you're doing these, if you don't mind, please like my videos if they help you. This kind of gives me, yeah, okay, this is working. Let me continue this. And if you have any suggestions, let me know. Please make up your work. As you remember, today is Monday, and then we've got till Thursday of this week, and then you have your spring break. Please use your spring break wisely. And if you have if you have some makeup work on that time, because we're going to pick up and go from there. I hope you have a blessed day, and I will see you again soon.